Hi everybody, how you doing? This is Mr. Dowse. This is the second video for the review for the test we're going to be taking in a few days, and I'm going to focus specifically on the special right triangle problems on this review. And I'm going to look at the 45, 45, 90 before I do any 30, 60, 90 problems, just because I think it's easier to do the 45, 45, 90, and that'll be a good segue into the 30, 60, 90 problems. So the idea is I've got kind of a couple examples, steps up here and a picture of what the 45, 45, 90 right triangle, like the setup is. So whenever it comes to the 45, 45, 90 triangle, keep in mind here that since we have two angles that are the same, the sides opposite those angles are going to be congruent as well. So a 45, 45, 90 triangle is actually an isosceles triangle because two sides are the same length. So in all the problems that we're going to solve here, you should have two sides that are identical in length because that's just one of the characteristics of a 45, 45, 90 triangle. So the first step I do here is I label the sides opposite the angles. And then notice on 25 I crossed out the x and the y here because I don't want the x and the y to be confused with the x's that I'm going to draw up here. So what we're going to do is we're just going to solve for the missing sides in all these problems. So the idea is I'm going to label the sides opposite the 45-degree angles as x. This is another 45-degree angle because mathematically this has to equal 180. So this guy I'm going to label as x as well. And then opposite the hypotenuse, I'm going to label as x square root 2. So do I know what x is right now? I do not. So I need to solve for x. So there's a math equation. I'm going to flip these around actually. I'm going to show you the long way of solving this, and then I'm going to show you the shortcut. And then I'm going to solve all these problems using the shortcut. So you don't have to do what I'm doing right now. I just want you to understand the process to get to the shortcut. So if I want to get x by itself here, you need to divide by the square root of 2. So I have x equals 7 over the square root of 2. Some of your teachers might let you get away with this, but I'm not letting my students get away with this because you're not supposed to have a radical on the bottom. So the goal is I need to get rid of the square root of 2. So to get rid of the square root of 2, you multiply the right side here by the square root of 2 over the square root of 2. And whenever you multiply fractions, you always multiply the numerator by the numerator and then the denominator by the denominator. So when I multiply 7 by the square root of 2, I'm going to leave it as just 7 square root 2. So I'm not going to plug this in my calculator. I'm just going to put them next to each other. And then when I multiply these together, if you ever plug this in your calculator, if you have two radicals that are the same and you multiply them by each other, they equal whatever's in the radical. So this bottom becomes 2. So when I simplify this, 7 over 2 becomes 3.5, and I have a square root of 2 at the end of this. So the answers here for both of these sides are 3.5 square root 2 and 3.5 square root 2. So hypotenuse is 7, and these guys are 3.5 square root 2. Now the idea here is there's a shorter way of doing this. I'm not going to expect my students to do all this work. Notice I went from 7, and I ended up with 3.5 square root 2. So the shortcut is you take whatever number, the whole number for the hypotenuse is, and you divide it by 2, and then you multiply it by the square root of 2. And that'll work for every single one of these problems. So for example, if I look at number 30, another example, so notice we have a 45, 45, 90, so it's turned on its side here. I know this is a 45, 45, 90 because these guys are equal to each other. So this is an isosceles triangle. So you're given here, x square root 2 is your 18. So the idea is, since this is my x square root 2, and these are my x values, all I need to do is take 18, divide it by 2, and multiply by the square root of 2. And these are your legs on the 45, 45, 90. So this guy is 9 square root 2, and this guy is 9 square root 2. So same idea as number 25, where since I have a whole number for the hypotenuse, I can just divide this by 2, multiply it by the square root of 2, and you get your answer. And that's the only problem I see where the hypotenuse is a whole number. Let's look at number 27, just because I've got a lot of space here. So on 27, I'm actually given the side measured label x. Again, I'm going to cross out x and y so I don't confuse people. But if I look at my little notes here, I'm going to label the side opposite the 45-degree angles as x, and the side opposite the hypotenuse, or sorry, opposite the 90 is as x square root 2 because that's the hypotenuse. And on this one, I actually know what x is. X is 7. So if this is 7, this is 7, and then this is going to be 7 square root 2. So that's going to be the end of this problem. And let's look at number 29, just because. 29 here, let's find the missing side. So let's cross out x and y. And notice, now I'm going to label the sides opposite the 45 as x, and then opposite the 90 is x square root 2. And my goal is to solve for x right now. And x right now is 14, so this side is going to be 14, and this side is going to be 14 square root 2. So that's the trick to the 45, 45, 90. So now I'm going to move on to the 30, 60, 90, and just call it quits to this video after I do that. So 30, 60, 90 problems are a little bit harder because on a 30, 60, 90 problem, you do not have two sides that are identical. So let me pull out my paper here and fold it up so we can actually see this a little bit better. So on a 30, 60, 90 triangle, since we have three angles that are different in length, you're going to have three sides that are different in length. And the side opposite the 30, we're going to label x. Opposite the 60 is x square root 3, and then opposite the 90 I'm going to label as 2x. So let's just start on number 19. So I have a 90 here, a 60 here, so this has to be the 30. Again, mathematically, these have to equal 180. So if I were to add these together and subtract from 180, I'd get 30 here. So my first trick is, let's cross out x and y so I don't confuse people. So opposite my 30 I'm going to label as x. Opposite my 60 is x square root 3. And opposite my 90 I'm going to label as 2x. So once I know what I've labeled the sides, my goal is to solve for x. And luckily, x is actually 8. I know what x is. So if I know what x is, I can just plug in an 8 for this x. So this long leg is 8 square root 3. And then if I take 2 times 8, because x is 8, the hypotenuse is 16. So the nice relationship on the 30, 60, 90 is the short leg and the hypotenuse. There's a really nice ratio where the hypotenuse is twice as big as the short leg. And then whatever the short leg is, you multiply it by the square root of 3, and that gets you the long leg. So since this is 8 square root 3. Since this is 8, 2 times 8 is 16, and I'm done with number 19. So 20 is going to be the same kind of problem. So 19 and 20 are very similar to each other. Now let's look at number 21. 21, let's cross out my x and y here so I don't confuse myself. I'm going to label my angles, or my sides. So opposite the 30 is x. Opposite my 60 is going to be x square root 3. And opposite my 90 is going to be 2x. So I'm not given x, or I'm not given x square root 3, but I'm given 2x. So 2x equals 11. So I divide both of these by 2. My x is actually 5.5. So this short side is 5.5. And since this x is 5.5, this is 5.5 square root 3 is going to be my short leg, sorry, my long leg. So this is 5.5. I double it to get to the hypotenuse, which is 11. Since the short leg is 5.5, I multiply it by the square root of 3 to get the long leg, and I'm done on this problem right here. And so number 21 and 24 are very similar to each other. So you're going to have the same kind of logic on that. And then let's do the last couple of problems here, and that's going to be my 22 through my 23. So 22 and 23 I think are the hardest kind of problems for when it comes to special right triangles. So again, let's put in my little cheat sheet here. Let's cross out x and y. Let's do 22. So this is my 30. So let's label the sides opposite these angles. So this is x. Opposite 60 is going to be my x square root 3. And opposite my 90 is going to be my 2x. So I don't know what x is here. And I don't know what the 2x is. So the math's is a little bit harder. So I have x square root 3 is equal to 12. And I'm going to solve this the long way. And then I'm going to tell you the shortcut. And then we'll quickly solve number 23 just kind of using that shortcut. So again, the same idea as what we did on the square root of, when we had the square root of 2 is, we're going to divide by the square root of 3 here instead. So x equals 12 over the square root of 3. And again, I can't have a radical on the bottom unless your teacher said so. But to get rid of this radical on the bottom, I'm going to multiply by the square root of 3 over the square root of 3. You multiply the numerators by each other, I get 12 square root of 3. You multiply the denominators by each other, you get the number 3. And if I simplify this, 12 over 3 becomes 4 square root 3, and that is my x value. So this guy is 4 square root 3. And if x is 4 square root 3, I'm going to replace my x with 4 square root 3, and 2 times 4 is 8. And so 8 times square root of 3 is going to be my hypotenuse. So the hypotenuse is 8 square root 3. The short leg here is 4 square root 3, and that's because the long leg was 12. Now you might see the shortcut here, right? So the idea here is whenever I had a whole number here, I end up dividing it by 3, and then multiplying it by the square root of 3. So whereas on the 45, 45, 90, since we had a square root of 2 here, we divided by square root of 2, sorry, on the 45, 45, 90, just to reemphasize the difference here, since we had square root of 2 here, we ended up dividing by 2 and multiplying by the square root of 2. But since on the 30, 60, 90, we have the square root of 3, we're going to end up dividing by 3 and multiplying by the square root of 3 to get your x value. So just to kind of shortcut, like in looking at number 23 here, let's cross out your x and your y here. This is my 30, so I'm going to call this guy x. This guy's my x square root 3, and this guy's going to be my 2x. So since I have my x square root 3 is equal to 8, it's a whole number, I'm not going to go through all this extra math here. I'm just going to take 8, divide it by 3, and multiply it by the square root of 3, and this is your x value. Now I'm not going to simplify this because 8 doesn't go into 3 equally. I'd get a decimal here, and I don't want a decimal. So my x is 8 square root 3 over 3, and if I take 2 times that, I'm going to multiply 2 by 8 here to get 16. 16 square root 3 over 3 is going to be my answer for the hypotenuse here. So again, if you're confused by some of this, just look at the videos I have on Google Classroom, and that should help you understand how to do special right triangle problems a little bit better. With that being said, I'm going to call quits this video, and I hope this helps out. Have a great day. Bye.